Hey guys, so let's talk about vectors and scalars and why it's important to know what the difference is when you're first starting out in physics. This is going to be the first of a 5-video series on vectors. So if you're just starting out in physics or you're a little bit confused about vectors, subscribe and make sure that you keep coming back for the subsequent videos, okay? So vectors versus scalars in physics, here's the deal. Vector quantities, so quantity would just be something like mass or time or force. That's all a quantity is, it's the amount of something. The vectors have both magnitude and direction to them. So there's certain things that it's like, it doesn't make sense for this quantity to have a direction to it, right? Like mass would not be a vector quantity. You can't have a direction to mass. Like we wouldn't say like 10 kilograms north. That doesn't make any sense. But there are some quantities that seem like they could have a direction, but we just don't attach a direction to them. So a vector has magnitude and direction, but a scalar quantity is magnitude only. And magnitude is just, again, it's like the amount of something. So if you have like a force of 5 newtons versus a force of 10 newtons, those have different magnitudes because they're different amounts of force. So in general, like that's kind of all the main differences between vectors and scalars, but let's talk about some examples of each of those quantities and what vectors actually look like, because we're going to focus here mainly on vectors. All right, so vectors, like I mentioned, have both magnitude and direction to them. Hang on. Have both magnitude and direction to them. So how would we then represent a vector quantity? We represent it with an arrow because arrows obviously can point in a certain direction, but we also can show the magnitude of a vector quantity by how long or short we draw that arrow. So a vector quantity that's like a larger magnitude, we would draw that with a longer arrow. If it's a smaller magnitude, of course, then we would use a shorter arrow. So for example, if I wanted to draw those two force vectors that I mentioned before, and we're talking about like a 10 Newton force to the right versus a 5 Newton force to the right, I'm going to draw those vectors as arrows. I'm going to draw smaller magnitude vectors shorter, larger magnitude vectors longer. Okay, so some examples of vector quantities in physics. And I'm going to mention just a couple of these that you're likely to be seeing at the beginning of the year, which one example would be velocity. So in this diagram that we're looking at here on the left, you see what we call in physics a motion diagram, which is something that we use to kind of qualitatively describe an object's motion over time. So we'll get more into this later on in another video, but these little vectors here, these little arrows, indicate the velocity at different moments in time. So in the beginning, we would see like a smaller velocity, and that velocity vector is getting longer and longer, which would tell us that this is an object that's speeding up because it's the magnitude of its velocity vector is increasing with time. We can also see the direction of motion of that object based on the fact that the vector is pointing to the right. On the right-hand side here, we have another kind of vector diagram, which is called a force diagram or a free body diagram. And the purpose of this kind of diagram is to show all of the forces that are acting on an object. So here we can see some examples of forces like a tension force, a normal force, weight, friction, but based on the directions that those arrows point in and their relative lengths, like how big they are compared to each other, we can see like kind of how big those forces are. So that's something that's important to indicate with a force diagram. So those are just some examples of vectors in physics. And I'll just name a couple of like scalar quantities. So again, like vectors, magnitude, direction, scalar, magnitude only. So like I mentioned before, mass is a scalar quantity, time is a scalar quantity, but speed is also a scalar quantity, which you might be like, well, I can tell how fast something is going, but also the direction that it's going in. But like how fast plus direction is velocity. But if we're talking about like just how fast, that's going to be like the magnitude of velocity or speed. Again, something we'll get a little bit more into later. Another scalar quantity is energy. So if we're talking about like kinetic energy, 10 joules of kinetic energy, that does not have a direction to it. It is a magnitude only. All right, so in video number 2, we are going to talk about like how do we speak the language of vectors? How do we draw them? How do we write the names of vectors? Because there's different kinds of notations that we can use when we're describing vector quantities, which include something called component form and magnitude angle form. And from there, we're going to get into some other vector skills like vector addition. So I hope that helps. If you want more of this vector information, make sure you subscribe, follow along. After our whole vector series, we're going to get into kinematics, so follow along with me.